Hello geometry students. Let's take a look at our 8.7 notes on vectors. So to get the idea of what a vector is, let's take a look at this scenario. Suppose your friend's car breaks down and he calls you to come pick him up. He says, "Please come get me. I'm 5 miles away from Garland High School." What else would he need to tell you? Well, you would need to know what direction to travel from GHS to find him. If you think of your friend, let's say this is Garland High School, and your friend is 5 miles away, well, he could be anywhere. If you think of all the points that are 5 miles away from Garland High School, he could be anywhere along this circle. So that's the idea of a vector. A vector will give us two pieces of information. It's going to give us distance, and it's also going to give us direction. Okay, so a couple things we need to talk about first is we need to get some vocabulary out of the way. So let's talk about this idea of a scalar. A scalar is a real number that describes the size or the magnitude of a quantity. So how large something is. So it's just a constant, it's a number. All right. So what is a vector? Well, a vector describes two things. It describes both the magnitude, whoops, let me get a pen, sorry about that. Both the magnitude and the direction of a quantity. So a vector can be represented by a directed line segment as shown below. So if you'll take a look at this directed line segment, it has an initial point, which we call the tail, and it also has a terminal or an ending point, which we call the tip. Okay, so that is a physical representation of a vector. You can see it gives you two pieces of information. It gives you direction and it also gives you distance. Okay, well, there are three ways that we're going to name a vector. So 3 ways to name a vector. Okay, one way is to name it kind of like we name an array. Start with the initial point and then name the terminal point. Notice those are capital letters. That's how we name points. And then the vector symbol it kind of looks like an arrowhead, except you'll notice it only has like one little thingy on it instead of two. So this is the symbol we use for a vector. So one way we name a vector is initial point and terminal point in that order, and then the vector symbol over the top. A second way we name a vector is we name it with a lowercase letter with a vector symbol over the top. Okay, kind of like we name a line, except we use a different symbol. And then the third way we name it, which is we don't use very often, you'll see it a lot in textbooks, but we don't use it very often, is a bold-faced. I'm going to just try and make this really thick looking. Okay, that is a bold-faced letter. So that's another way that you'll see vectors named. So let's talk about the two components of a vector. Let's first of all start with the magnitude of a vector. And I see a little typo we need to fix. That's supposed to be a vector symbol over that. So if you could fix that. Okay, so let's start with the magnitude of vector AB. Okay, we denote it like this. We represent it with absolute value symbols. So we name the vector and put absolute value symbols around it. Okay, that is how we denote the magnitude of a vector. And that magnitude is the length of the vector from the initial point to the terminal point. Okay? The other component of a vector is direction. The direction of a vector can be represented as an angle that it forms with the horizontal. Or as a measurement between 0 degrees and 90 degrees, either east or west of a north-south line. So this first example shows the way we'll generally express the direction of a vector. You'll notice that this vector AB is 30 degrees relative to the horizontal. That's normally how we will describe the direction of a vector, but sometimes you'll see it like this. In this direction, we have this second way to represent the direction of a vector, where it is a measurement between 0 and 90 degrees east or west of a north-south line. So this vector AB is 60 degrees east of north. Okay, so if that way is north and that way is east, it's 60 degrees east of north. So two different ways to represent direction of vector. We will usually use this first one. Before we move on and talk about what a resultant vector is, let's take a look at these study tips, some things you need to know. First of all, parallel vectors. Parallel vectors have the same or opposite direction, but not necessarily the same magnitude. So you'll notice that the vector A and vector B are parallel. They have different directions. They have opposite directions. They also have different magnitudes, but you'll see that they are parallel. Now this idea we'll use quite a bit. Opposite vectors. Opposite vectors have the same magnitude but opposite direction. So this first vector is vector A. You'll notice that this one is the opposite of vector A. Same distance but opposite direction. And then equivalent vectors have both the same magnitude and the same direction. So you'll see here that vector A and vector B, same distance, same magnitude. Okay, so now let's talk about what a resultant vector is. A resultant vector is the single vector that is the sum of two or more vectors. So what we're going to do now is we're going to use two different methods to find the resultant vector of vector A and vector B. Okay? So the first method is called the parallelogram method. So let's just jot that name down. Okay, it's called the parallelogram method. Parallelogram method. Okay. Now, when you think of parallelogram method, I want you to jot this down. Think this, tail to tail. Because what we're going to do is we're going to sketch these two vectors, and when we sketch them, we're going to connect them, and we're going to connect their tails. So the first thing you do is you're going to mimic vector A. So this is going to be a freehand drawing. It's not going to be perfect. What you want to do is try to draw vector A by mimicking its distance and its direction. And we're going to draw and label it. So vector A looks something like that. Okay, there's vector A. Okay, so I'm trying to mimic its distance and direction. Now we're also going to mimic vector B. So again, try and copy its distance and direction, but make sure you connect the two vectors at their tails. Okay, so that looks pretty good. Okay, so now the reason why this is called the parallelogram method is what we're going to do now is, as best you can, again, this is a freehand drawing, try to connect, it's not connect, but try to complete the parallelogram. So we complete the parallelogram, and then our resultant vector is going to be the diagonal of that parallelogram. Its initial point will be the common point, the common tail point of vectors A and B, and then its terminal point will be here. So this vector is what we call vector A plus B. It's called a resultant vector. Okay, so that's called the parallelogram method. Now the second method we're going to do is called the triangle method. Okay, the triangle method, when you think of that, I want you to think tip to tail, okay? Because when you do the triangle method, we're going to start by mimicking vector A. So vector A looks something like this. Okay, again, I was trying as best I could to mimic the distance and the direction of vector A. Now, we're also going to draw vector B, but when you draw vector B, you want the tail of vector B to be connected to the tip of vector A. So it would look something like that. It looks like I should have drawn this a little lower, so I'm drawing into the words. But that is our vector B, okay? And now this is called the triangle method because we're just going to finish the triangle. Start with the initial point of vector A and draw a vector to the terminal point of vector B. So this red vector is what we call the resultant vector, vector A plus vector B. So now let's try this next example. This one says use two different methods, meaning the parallelogram method and the triangle method, to find vector C minus vector D. Well, the first thing we need to do is rewrite the problem. Vector C minus vector D is the same thing as vector C plus the opposite of vector D. So we're going to find the resultant vectors by adding, or the resultant vector by adding together vector C and the opposite of vector D. Remember, we talked about what an opposite vector is. Same distance, but opposite direction. So the first thing we're going to do, let's start with the parallelogram method. So we'll do it first. So parallelogram method. Okay, so the first thing we will do is we will mimic vector C as best we can, try and mimic this distance and direction. Okay, so vector C will look something like that. That looks pretty good for vector C. Okay, now since this is the parallelogram method, remember that's tail to tail. So now I'm going to mimic the opposite of vector D. So let's over here, let's just draw, here's vector D. Let's go ahead and just draw what the opposite of vector D would look like. It would be the same distance but in opposite direction. So this would be what the opposite of vector D would look like. So what we're going to do is draw the opposite of vector D and connect its tail to the tail of vector C. So it would look something like that. So this is the opposite of vector D. Now, since this is the parallelogram method, what we're going to do next is just finish the parallelogram as best you can. Okay, and so the resultant vector will be the vector that whose initial point is that common point, that common initial point, and then draw a vector to the just draw the diagonal of the parallelogram. So this red vector is the vector vector C plus the opposite of vector D, or in other words, it is also, it's a vector symbol, it is also vector C minus vector D. Okay, so that's the parallelogram method. Now let's do the same problem now with the triangle method. So the triangle method, okay, remember that is tip to tail. So we're going to start by mimicking vector C. So again, try and copy this distance in this direction. So vector C looks something like that. So there's vector C. Now, let's draw vector, this vector, the opposite of D, but you want its initial point to be at the terminal point of vector C. So we'll draw it. So here is the opposite of vector D. Oops. Hold on, let me fix that. I got my symbols mixed up. Okay, opposite of vector D. Okay, now for the triangle method, you start with the initial point of your first vector and draw to the terminal point of the second vector. And our resulting vector then would be vector C minus vector D. Or in other words, vector C plus the opposite of vector D. Now, one thing I want to point out is it doesn't matter, and I meant to do this in the last example, it doesn't matter whether you use the parallelogram method or the triangle method. You'll notice that our resultant vector should look the same no matter which method you use, okay? So now let's talk about vectors in the coordinate plane, in other words, in an xy plane. A vector in the coordinate plane is in what we call standard position, okay, if its initial point is at the origin. Okay, so if you look over at the picture, this red vector is in what we call standard, the red vector and the blue vector are in what we call standard position because its initial point is at the origin. Now, if we have a vector in standard position, then it is uniquely described by its terminal point. So that terminal point in our example would be the point x comma y. So you can see in this diagram that this blue vector is uniquely described by the point Pxy because the x value and the y value of this point uniquely describes a distance and a direction for this vector. Okay. Now the next thing we're going to talk about is a new symbol you've not seen before, and that's called component form of a vector. So component form of a vector kind of looks like an ordered pair in that you're going to see x comma y, except the grouping symbol is a little different. The grouping symbol isn't parentheses, but it's these little pointy symbols, okay? So when you draw a component form or write component form of a vector, make sure that your grouping symbols look different from an ordered pair. So component form describes a vector Oops, sorry, that says describes a vector twice. Let me mark that out. Sorry about that. Okay, so component form describes a vector with any initial point, okay? So we can only describe a vector by a point if it is in standard position. Its origin is at its initial point is at the origin. But if we have a vector anywhere else in the coordinate plane, then component form can describe that vector. Component form of a vector with initial point x1, y1 and terminal point x2, y2 is found by simply subtracting the x values to get the x value of your component. So x sub 2 minus x sub 1 and, x sub 1. And let me write that so you can read it. Sorry. X sub 2 minus x sub 1, and then take y sub 2 minus y sub 1 to get the y value of your vector. Okay, so let's write component form for these vectors. And if you would, make sure that those symbols, if they're not already fixed on your notes, fix those. Okay, so let's write the component form for vector CD and vector XY. So make sure you pay very close attention to which point is the initial point and which point is the terminal point, because this will be your x1, y1. Let's go ahead and jot that down. So this is x1, y1, and this point will be x2, y2. So to describe vector CD in component form, what we'll do is we'll take the difference in the x values, so that's going to be, and make sure you take the x value of the tail minus the x value of the tip, and then take the y value of the tail, which is 1, minus the y value of the tip, which is negative 1. Of course, that's this, negative 1. Of course, that's the same thing as adding a positive 1. So in other words, the component form of vector CD is 4, 2 by just doing the arithmetic. Now let's find component form of vector PQ. Okay, so first of all, make sure you pay attention to which is your initial point and which is your terminal point. So you're going to take the terminal x minus the initial x, so that's negative 3 minus a negative 1, which of course is the same thing as adding a positive 1. And then to find the y component value, you'll take the terminal y minus the initial y, so that's going to be negative 1 minus 3, okay? And then do the arithmetic. So component form for vector PQ is going to be negative 2, negative 4. So now let's take a look at this next example that says find the magnitude and the direction of vector R. Written in component form is negative 4, negative 5. Okay, so to find magnitude and direction, we're going to have to do two different things. Let's first of all talk about the magnitude. Now remember, magnitude of a vector is its length. Okay, so if I want to find its length, the length of vector R would be the same as the distance from this point 0, 0 to this point whose coordinates are, let's just jot that down, it would be negative 4, negative 5. Okay, so remember the distance formula. Here, I'll just jot it down just in case anybody has forgotten it. The distance formula between the points x1, y1 and x2, y2, remember, would be the square root of the difference of the x values squared plus the difference of the y values squared. I hope you can read that. So distance formula. Okay, so let's find the magnitude of this vector R. In other words, the distance from this point 0, 0 to this point negative 4, 5. Okay, so the way we would indicate the magnitude of vector R is name the vector and then remember put absolute value symbols around it. Okay, so the magnitude of vector R would be the square root of, now remember when you use the distance formula, just put a big old radical and then put parentheses squared plus parentheses squared. Now inside those parentheses, we're going to write the difference of the x values. So that would be negative 4 minus 0 in the first set of parentheses, and then the difference of the y values, negative 5 minus 0. All right, so now let's do a little bit of arithmetic. So that would be equal to, no, maths. I'm having all kinds of issues here. Okay, equal to the square root of, let's see, negative 4 minus 0 is negative 4, so that would be negative 4 squared plus negative 5 minus 0 is negative 5 squared. So that's equal to 16 plus 25, and we get the square root of 16 plus 45 is 41. Now, let's just leave it in simplified radical form. This is not going to simplify any because 41 has, the radicand 41 has no factor other than 1. That's a perfect square, so we'll just leave it in that form. No need to write it in a decimal unless you have specific directions to tell you that. Usually you'll just leave your answer in simplified radical form. So we have done the first part of this example. We have found the magnitude. The next thing we need to do is find the direction of vector r. So let me just clarify what I mean by direction. The direction of vector r is the angle that it makes, that the vector makes with the positive x-axis. Okay, so the direction of our vector would be, if you were to take a vector that started in standard position, which would have its origin at, its initial point at the origin, and it would lie along with the, lie along the x-axis, then we would have to rotate it over 180 degrees to get here, okay? So the angle that it makes with the positive x-axis in this case is going to be an angle bigger than 180 degrees. So to find out what that direction is, we're going to have to figure out what this angle theta is, and then once we figure that out, we'll add it to 180. So I hope that makes sense to you, that our direction is going to be 180 plus theta. So let's see if we can use some past skills to figure out what theta is. Okay, so to find our direction, let's use some trig. With respect to theta, okay, 5 is the opposite, the measure of the opposite leg, and 4 is the measure of the adjacent leg. So opposite and adjacent, remember, we'll want to use tangent. And since we're looking for the angle, that's when you use inverse tangent. So to find theta, theta is going to be equal to tangent inverse of the opposite over adjacent, or 5 over 4. So now you'll get a calculator. Make sure that it is in degree mode, and look up tangent, or you could look on a table. If you want to Google a trig table, you could also find it that way. But tangent inverse of 5 over 4 is approximately equal to 51 degrees. We'll just round to the nearest degree. Okay, so now let's give our two answers. We were being asked to find two things, magnitude and direction. Okay, so magnitude is going to be the length of that vector. So the magnitude was the square root of 41, okay, and then the direction of our vector is going to be 180 degrees. It's how far it's rotated from the positive x-axis. So that's going to be 180 degrees plus theta, which was 51 degrees, for a total of 231 degrees. Now, before we go on to the next example, I just want to make a note about this idea of the direction of the vector. So let's talk about some different scenarios. If you have a vector that lands in quadrant 1, okay, then all you need to do is find out what this angle is, the angle that it makes with the x-axis, okay? If your vector is in quadrant 2, okay, to find out what this angle is, you would need to find angle, I'm going to call this angle theta, and you would need to take 180 minus theta, okay? If you're in quadrant 3, like the example that we just did, it would be 180 plus angle theta. So then the other scenario would be if we were in quadrant 4, and probably the easiest way to find the direction of quadrant 4, that would be a rotation that's short of 360 degrees, right? So you would figure out what angle theta is, and then you would take 360 minus theta. Okay, so you'll get some more practice in your homework on that, and be sure and ask me if you have any questions. So let's go ahead and finish up with this idea of vector operations. So if A, B, and C, D are vectors and K is a scalar, remember K is just a constant, it's just a value that's a constant, then the following are true. Remember, this is a vector in component form, and here's a second vector in component form. Vector addition is achieved. We can take vector AB plus vector CD by simply adding their x values and adding their y values. Vector subtraction is where we just subtract the x values and subtract the y values. And then scalar multiplication is just where you take the components of a vector and you multiply it by a constant. So Ka times Kb. So let's take a look at some examples like you'll see in your homework. So given these vectors in component form, perform the vector operations and check them graphically. So you'll be doing this in your homework. You'll do the arithmetic and then you'll show a graph to check your work. Now, when you go to show a graph, these three examples all use the parallelogram method. I think that's probably the easiest for these problems, but you could also use triangle method as well. And you could check your work graphically using the triangle method if you wanted to. Okay, so let's start with the first one. So to find the sum of vectors R and T, okay, we're just simply going to take, to find the sum, we're going to take the sum of the x components, so that would be 3 plus 1, okay? So the x component of vector r plus the x component of vector t, and then we're going to do the same thing with the y coordinates. We'll take 4 plus negative 2. So as you know, 4 plus negative 2 would be the same thing as 4 minus 2, okay? So our resultant vector would be 4, 2. So wherever that initial point of the original vector, I'm sorry, never mind. So now to check that, the easiest way to do would be to draw the two vectors in standard form, meaning that their origin, their initial point is at the origin. So this is vector r, okay, with components 3, 4, and here's vector t with components 1, negative 2. So draw those two vectors, finish the parallelogram, and then you draw your resultant vector. Now, since we're drawing this in standard form, notice what its coordinates would be. Its coordinates are 4, 2, which is exactly what we got arithmetically. Okay, so let's take a look at example B. Okay, example B says we're going to take vector S minus vector R. So remember, that's the same as taking vector S plus the opposite of vector R. Okay, so the opposite of vector R obviously would have opposite components, an opposite x component and an opposite y component. So maybe I should just jot that down for you. So if vector R is 3, 4, then the opposite of vector r would be negative 3 and negative 4. Okay, so now let's add together s with components 5, negative 1. Let's add that to the opposite of r. So s plus the opposite of r is going to be 5 plus negative 3. Okay, I just took 5, the x component of vector s, plus negative 3, the x component of vector r, and then to get the y component, we're going to take negative 1 plus negative 4. Negative 1 plus negative 4. And of course, you could write that 5 minus 3 and negative 1 minus 4 if you want, but your final answer is going to be 2, negative 5. Okay, let's take a look at one more example. Now this one we're going to use scalar multiplication and multiplication. So we're going to take 2 times vector t. So let's just write that down first of all, what that would be. So 2 times vector t, we just simply double the components of vector t. So if t is 1, negative 2, then 2 times vector t would be 2, negative 4. And then let's also jot down what the opposite of vector s would be. That's just the opposite components of s. So if s is 5, negative 1, then the opposite of s would be negative 5, positive 1. So -5, +1. All right, so now let's add. Let's go ahead and add. What we're gonna do is we're gonna take 2 times vector t plus the opposite of vector s. Okay, so we're just going to add these components. That would be 2 plus -5. I'm just going to write it as 2 minus 5, and then -4 plus 1. So your final answer turns out to be -3, -3. Okay, now again, we can check that by simply here's vector 2t, okay? Remember, t was 1, -2, so 2t is 2, -4. So there's vector 2t. Here's vector opposite of s, okay? So draw those two vectors, complete the parallelogram, and then draw your resultant vector. You'll notice that the coordinates of this point are -3, -3, which is exactly what we got arithmetically. Okay, so go ahead and give your homework a try, and if you have any questions, be sure and let me know.